All right, here is exam number 5. I guess my way, or the way I was expecting you all might do it, but from more like first principles. Okay, so once again, oops, got that. Oh, gotta do that. Okay. We have our f1 of x1 is 0.2 on 0, 5, and f2 of x2 is 0.1 on 0 to 10. Okay. Now we want to look at y equal x1 minus x2, which I can write as x2 equals x1 minus y, like that. And now we're on our rectangle. So we have our axes here. There's 5, there's x1, there's x2 and 10. Okay, and this line is, heading through here like this, and the y-intercept here at any given point, whatever we do, is at pull this down here, this is at negative y. Okay, and if we're looking at x1 minus x2 is less than or equal to y, because again what we want to do is we'll first come up with this x1 minus x2 less than or equal to y, like that, and so that will become our integral. Then what we see here is that that inequality, that's looking this direction. Okay, so it's all that shaded region. Okay, so this is 10 up here. So again, y can go between minus 10 and 5. And so this 10 up here is actually y equal minus 10. And so that's the lowest, right? And we would have 0 area above that. And so we start looking, okay, what happens as this line comes down this way? And we see that when we get to here, where it runs through 5, 10 there, and so this would be a 5 here. We see that we can do that integral, but as soon as we get past y equal negative 5, and we're down into something like this line, then we'll have to do that integral slightly differently, the bounds on that. And so what we have is, this is going to be 3 different cases, just like it was with the Keaton case, Keaton approach. How about that, Keaton? You're famous. And so, we're going to do an integral, and as we look at this, we see that, well, x1 can go from 0 to 5, but x2, then if I look here, goes from our x1 minus y up to 10. So we have a 0 to 5, and what did I say? x1 minus y up to 10. And then we have our point 02. again, because that's our joint PDF, and dx2 dx1. So we have that when we are between -10 and -5. Now, if I move to, say, a line that looks like this one, oops, wrong line. Let me erase a little bit here. Let's get rid of that so we can see a little better. Now, as long as I'm in here, until I get to this line right there, I will have the same kind of bounds. And so as I look at that, you see I'm again going from, in that case, x1 goes from 0, right? Yeah, it goes all the way. Oh, yeah, I messed that up back here. I'm sorry. These lines, they don't, the x1 does not go all the way to 5, so I messed that up. Let me fix that. So the inner part's fine, but the outer part, where is this? So this is getting really messy in here. So let me kind of just draw it over here. So this is at 10. We're doing this, and we know this is minus y. And so, what's this value right here? And that value is 10 plus y. Okay, does that make sense? If y is -10, we would be back here at x equals 0. And as y increases up to -5, we would finally make our way out to that corner. So that's 10 plus y. So that needs to be 10 plus y. So sorry about that. Okay, now we're on to the second one, which does go up to 10 and 5 and so forth. So this is 0 to 5, and x1 minus y up to 10 of 0.02 dx2 dx1, and that's -5 less than or equal to y less than or equal to 0. Okay, so again, we can erase a little bit. So we can see better what we have here. So now we are between a line that does that and a line that does that. Okay, so we're on some line and looking up here. And so on every one of those lines, the x1 goes all the way across from 0 to 5, so that's what I have here. And the x2 variable starts at this line, which we know is x1 minus y, and goes all the way up to 10. Okay, so we've got that one. And then finally, for our last one, we have something slightly different here. So now, okay, I'm going to erase that. At this point, now I'm looking at a line that maybe does something like that. And looking up here again. And so you see, actually, I've got two pieces. I've got a rectangle, which that's easy. I know the height's 10, and the width of that rectangle is, what the heck is the width of that rectangle? I guess that is minus y, right? Because if this is minus y down here, say y is at that point equal to 3. Oh yeah, so not minus y, that would just be y. Okay, so I'm doing a rectangle, which is just 10 times y, and then a trapezoid here that I have to do with integration. So actually, let me do my rectangle first. So I have my rectangle of 5, oops, not 5, 10, because that was the height there, 10 times y, and then plus my integral, and that went from y to 5, and from x1 minus y to 10 of 0.02 dx2 dx1, and that is for 0 less than or equal to y less than or equal to 5. Okay, so I've got my 3 integrals for each of the possibilities for y. And now the inner integral is the same every single time. So if I rewrite this, and so this is where you can kind of see, at least somewhat, the change of variable idea is that, you know, this inside part is the same with x minus y. Now there is a little difference out here with this third one where we added that rectangle, but at any rate, we have 0 to 10 plus y, and the inside of this thing with respect to x2 is always just going to be 0.02 times 10, which is 0.2, and then minus our x1 minus y, so we have 0.2 plus 0.02 y and minus 0.02 x1, and this is all dx1, and that's minus 10 less than or equal to y less than or equal to minus 5. We have our integral from 0 to 5 of this same thing, 0.2 plus 0.02y minus 0.02x1 dx1 minus 5 less than y less than or equal to 0. And then finally our last one from well, oops, I forgot my 10y, so let me put that in there. Okay. Oh, and I kind of messed that up too. I took that rectangle, I said it's 10y, but I didn't multiply by the 0.02. So that should actually be 0.2y. Thanks for yelling at me. I could hear you through the video that I forgot. Because you're just doing an integration up here. With that rectangle, I'm just doing the integration. But the integration is the base area times the height. Height as in a rectangular prism, and the height is 0.02. So I've got my 10y times the 0.02, and so I almost messed that one up. Okay, so 0.2y, and then plus, what the heck was that? Y to 5. Y to 5. And that is my 0.2 plus 0.02y minus 0.02x1 dx1. 0 less than y less than or equal to 5. Okay, and so we have those integrations with respect to x1, and so we get, what the heck do we get? Well, the first two are kind of nice because they just they go from 0, so we won't get anything for the lower part. So we have our 0.2 times 10 plus y. So what the heck is that? That is 0.2 times 10 is 2, so I guess we get a 2 plus 0.2y. And then we'll get a 0.2y plus 0.2y, I think. And then 0.02y squared. And then here, when we do this last part, that's going to be 0.01 x1 squared. And so we're going to get plus 0.01 times 10 plus y squared. And that's from our negative 10 less than or equal to y less than or equal to negative 5. Now 0 to 5, so we'll just get 5 times 0.2 is 1, and 5 times 0.02 is 0.1, so plus 0.1y. And then we'll get our 0.01 times x1 squared. So that's going to be plus 0.01 times 25. So that's 0.25. And that's from minus 5 less than or equal to y less than or equal to 0. And let's see, and then finally I have a 0.2y. And now 5, I know how to put that into there because I just did, so that's plus 1 plus 0.1y plus 0.25. And then minus putting y into there, so that's minus 0.2y minus 0.02y squared, and then plus 0.01y squared, and that's 0 less than or equal to y less than or equal to 5. Whew. So this is definitely a bit longer way than if you make that change of variable. So that, like I say, I really like that. That was nice. So trying to simplify this whole darn thing, okay, I'll square this thing out. I'll get 10 squared, which is 100, times 0.01, which is 1, so it looks like I get a 3. And then, how about the y's? I get a 0.2 and a 0.2y, and in here I'm going to get 20y times 0.01, so that's 0.2. So I think I get 0.6y. And then I get plus 0.01 y squared. Oh, 0.03 y squared, because I've got that one, 0.03 y squared. Okay, and that is from negative 10 less than or equal to y less than or equal to negative 5. Okay, so I'm going to pause for a minute, check my notes to make sure I'm not way off here and too far to come back to fix it. Okay, as I thought I might have done in just doing this, as I went, I did mess up a negative right there. So back here, that was minus 0.02 x1. You all didn't yell loud enough. This should have been a minus. So that should be a minus. And then if that's a minus, then when I put all this stuff together, I no longer get that. I get this thing, so 1 plus 0.2y plus 0.01y squared. So I'll erase this one. Okay, so we have that. And, you know, part of my checking that was just to look at putting in -10 and -5. If you put in -10, you will get 0 out of this, and if you put in -5, you do get 0.25 from it. So then we have 1 plus 0.1y plus 0.25. Oh, well, so that's 1.25. So again, let's kind of check to make sure that seems right. So it's 1.25 plus 0.1y. And in this case, y is supposed to go from -5 to 0. Well, obviously, yeah, I've got a sign error somewhere in there with the 0.25, because if I put 0 in there, I get 1.25. Well, that's not right. And if I put -5 in there, I get 0.75. Well, it shouldn't be 0.75, it should be 0.25, because that's what I got from that one. So let me take a quick look. I'll come back. Well, that was much quicker for me. You don't really notice, but once again, of course, I had a sign error. I don't know why I kept forgetting that negative on that 0.02, but I did. So that's minus 0.25. So this simply becomes a 0.75. And now it works out okay. At -5, I get 0.25, just like I got up here, and I should get those to match. And then that should just be a strict inequality. And then at 0, I get 0.75, which seems reasonable. Well, let's see if I got the signs right on this last one. Okay, so this last one, it looks like I have a 0.2y here and a minus 0.2y there. So they disappear. I see a 1.25. Hopefully that's okay. Oh, no, I know that that is a sign error now because I just copied it from up there. Oops, put that. Okay, that is a sign error on that. Hopefully the rest of these are correct. So it looks like I should have 0.75 plus 0.1y, and this is from 0 less than y less than or equal to 5. And then a minus, it looks like, 0.01 y squared. Now, if I put in 0, I definitely get the 0.75, which I got up here with 0. If I put in 5, I get a 0.5 here and a minus 0.25 there, and that works. Okay, so I am happy with this one. And so, you know, this, again, I had notes on this, but I didn't follow them very closely as far as, you know, just looking at what I had written before. Partly because we all make mistakes as we do our stuff. You need to be able to check it, you know, you need to think about how do you check it. And so I checked those. I'm pretty comfortable with those. And now, okay, remember this was f of y, and so I want little f of y, the PDF, And so I need to take a derivative, and I get up here 0.2 plus 0.02y, and that is from -10 less than or equal to y less than or equal to -5. I get 0.1, and that is -5 less than or equal to y less than or equal to 0. And I get 0.1 minus 0.02y, and that's 0 less than or equal to y less than or equal to 5. And that is what we got before with doing it with the change of variable. And so, both methods give the same answer. In the end, doing it this long way from the first principles, a lot more prone to error. Certainly I was a lot more prone to error. And so, that's something to think about. But on the other hand, not everything can be done by that change of variable method, and so you do have to do things from first principles most of the time, and it does get messy. And of course, if I had just plugged these integrals into a technology or something like that to evaluate them, well, yes, I would, unless I had just done a typo or something, I would have gotten the right answers that way. But so technology can help me. Just once I know it, I've set it up okay, then I can do the computation that way. And but I again, as I often point out, I think it's important for you to realize, we all as mathematicians make mistakes as we do things, even in our just basic calculation. I might be worse than many others, but I don't know that that's true. I've seen plenty of mistakes from my colleagues. And so, I think it's important for you to realize that, well, what makes us successful as mathematicians is not that we don't make mistakes. It is that we think about our answers once we get them, we check them, and we look to see, do they make sense? And if they do, then we start feeling very confident about it, and so forth. So here I am confident about this answer, and it also matches the answer I got when I did the change of variable. And so at that point, I'm very confident about this, but it took a lot of work. Math takes a lot of work. All right, so there is number 5.